This screencast video attempts to show you how to use a calculator, a handheld calculator, in this case, my handheld graphing calculator emulator. It's actually on my computer here at home, but it essentially looks just like the template you see on the left side of the screen. So these are all for those four problems, those practice problems from section 4B, 4C, and 4D that I've just sent an attachment to you all about. The first problem is investing a one-time lump sum deposit of $12,500 in an account that earns 5.375% APR compounded daily. And the question is, how much money will it be in after 7 years? So I'm going to start off with the original one-time lump sum principal amount of 12,500. Most calculators will require you to use a multiplication, even though mine doesn't. I will still put it there. Then you're going to open a parenthesis for the base, which is 1 plus the APR of 0.05375. That's the decimal form of 5.375%. You're going to divide it by 365 because that's the value for n for compounded daily. In my calculator to do exponents, I'm going to use this caret key, and it looks similar when we do this in when I show you later in a different video how to do it in the Google search engine. I'm opening a parenthesis for the exponent, and that's ny value of 365 times 7, because this is the request was how much money will be in the account after 7 years. That value to the closest penny should be $18,209.64. The second question asks, how much money will be in a savings account when you make regular monthly deposits? $375, earning 6.19 APR compounded monthly for a full 28 years. So that's one of the formulas that hails from section 4C. The formula before we used up above was from 4B. So we'll start with the monthly payment of $375. Again, even though my calculator doesn't require it, I'm going to put the asterisk for multiplication because many of your calculators will require that. Remember, the amount at the end is a large amount, so that larger amount in the formula, the larger numerator of the base raised to the power minus 1 is all in parentheses. So I have to open the parentheses for the numerator and another parenthesis for the base, which is 1 plus the decimal form of 6.19%. And I'm going to divide that by 12 because this is supposed to be for compounded monthly. And now I'm going to raise that to the power of 12 times 28. And my calculator doesn't require me to put the ny value in parentheses, but yours may. You also need to figure out how to get out of the exponent. Different calculators do that differently. I push the right arrow to make sure that I'm not subtracting 1 from the exponent, but subtracting 1 from that entire base raised to that exponent power. When I close the parenthesis, that's the entire numerator. I'm going to push the division bar for the fraction bar and put the decimal form of 6.19% divided by the appropriate n value of 12 for compounded monthly in the denominator. And those should be, that account should have built to $336,851.53 to the closest penny. The third question asks, what would the monthly payment be, the required monthly payment to build up $160,000 potentially for a college fund when it's an account that's also earning interest compounded monthly, but at an APR of only 4.75%. And this was somebody who may have started this maybe 2 years into their child's life so that it's ready when they're 18. So they only had 16 years to save. So this one is going to give us the small payment that arrives at the large amount of $160,000. So now the smaller quantity is in the numerator. We're going to use another formula from section 4.C, and it's the one where just the APR over N is in the numerator. So this is the original $160,000, or the amount you want the account to build to after 16 years. I'm going to use multiplication again, even though I don't need to for my calculator, and put the decimal form of 4.75% in the numerator and divide by 12 because this is also an account earning compounded interest compounded monthly. And now I'm going to divide by all of the denominator. So I open a parenthesis for all the denominator and another one for the base, which is 1 plus 0.0475, again divided by 12. And all of that is going to be raised to the power of 12 for compounded monthly times 16 for 16 years. And even though my calculator doesn't require it, I am putting that in parentheses as well. Many of your calculators will need to. Getting out of the exponent to subtract the 1 to finish the formula, closing the parenthesis, computing that the monthly payment required to achieve $160,000 when a compounded monthly account with 4.75 APR for 16 years, the monthly payment is $557.97 to the closest penny. The last question hails from section 4.9, and that's where you you have borrowed $28,000 potentially for a car probably, and you've done this through a car dealership that is charging you 3.99% APR for your loan. And it's also compounded monthly, and the car loan is over 5 years. So to find the monthly payment for that loan, we start off with the amount that you borrowed, which is also referred to as the principal. Again, I'm going to put the asterisk, even though it's not necessary for my calculator, but it may need to be used for yours. And that decimal form of 3.99% is 0.0399. I'm going to divide it by 12 again because most of these payments, certainly most loan payments, are done monthly. And that's why they compound monthly. So I'm dividing by the appropriate value of n. Now I'm going to divide by all of the denominator, but the formula is a little different from section 4.9 for loan payments. It starts off with 1 minus, which I put inside parentheses for the entire denominator, and another open parenthesis for the base, which is 1 plus, again, the decimal form of 3.99% is 0.0399. You got to divide by 12 because it's compounded monthly. And remember, the exponent is negative ny. So I'm going to raise that to the power of negative 12 times 5 because this was a loan over 5 years. Be careful not to use the minus button for negative if your calculator has two different buttons. Mine does. I'm going to start off with negative 12. Some calculators require you put the 12 first and then the negative to make it negative. Mine does the negative first. I'm multiplying it by 5 for 5 years, and I'm just going to get out of exponent land to close that parenthesis for the entire denominator. So if you borrow $28,000 for a car at 3.99% APR, compounded monthly for a 5-year loan, your monthly payments will be $515.54. Thanks for sticking with it through the whole video.